All right, hello everyone. My name's Trevor Edwards, and today I'm going to be talking to you all about running Airflow inside. Someone has their mic
No, pues
on.
una cosa en
Could
vivo.
you turn that off?
Es una cosa en vivo, este evento. Un
Hey,
evento.
Bernie, could you turn your mic off? Thank you, Bernie. All right, so back to this. I'll be talking to you about running Airflow inside of Google Cloud Platform. And you also see the name Peng Lu up on the slides. He was originally going to give this, but he had some last-minute business travel. So feel free to raise your hand, ask questions throughout the presentation. And a little bit of background about the architecture I'm going to show today. There's been some increased interest about Airflow within Google pretty recently, and probably at a lot of your companies as well. So part of what my team has worked on is designing an architecture to share internally at Google, just in case any other teams are looking into using it. So about me, I'm a software engineer at Google. I've been there for 9 months working in data analytics at Google Cloud Platform, and I graduated from Cornell last May. All right, so an outline of what I'm going to talk about today. Executors, although it seems like we just heard everything we need to hear about that. Airflow infrastructure requirements, securing the Airflow web server, Airflow on GKE, DAG and data distribution, scaling Airflow, and production monitoring with Stackdriver. So, brief overview of executors. So we were looking at executors when deciding what to use for our design and architecture. So first we looked at the local and sequential executor, and it seems like a lot of people here are using that. So it is easy to set up, and it seems like it's capable of doing a lot. But unfortunately, it's also a single point of failure. You know, if your machine goes down, there goes everything. And it's not horizontally scalable. So it seems like some of you might be eventually hitting those walls where you can't just keep scaling up. So we didn't want to start off with a design that would run into that wall. We looked at the Mesos executor, and the issue with this is it's less supported. I mean, it's in the contrib folder compared to the Celery executor, which is more supported and not in the contrib folder. So we decided to go with the Celery executor. So with that, you know, you can still start somewhat small. You'll need a few nodes, which I'll talk about in a bit, but it's also ready to scale without too much issues. And of course, the fourth executor, Kubernetes executor, we're looking at it, but we haven't made an architecture for it yet. So we'll be talking about the Celery executor today. So infrastructure requirements, we want to support the Celery executor. We want secure access to the Airflow microservices, data, and UI. We want a scalable, configurable Airflow setup and fast scalable storage if we decide that we need a lot of storage. Low management overhead and production ready monitoring. So this is just a preview of the overall architecture. I'll show a slide just like this in a little bit, but just to give you a quick overview. So like we're using Google Kubernetes engine to run the Airflow scheduler and worker. We've got Redis for Celery. We've got Cloud SQL running the Airflow DB. We're running the Airflow web server on Google App Engine behind identity-aware proxy. And then we're using Google Cloud Storage for things like holding our DAGs, serving logs, etc. So let's dive into how we're securing our Airflow web servers. So a lot of you might have like monolithic Airflow setups, maybe not. What we decide with this architecture is your Airflow setup's going to be at the scale of maybe your team or just yourself. So you're the only person, or your team's the only group of people putting DAGs in a particular Airflow setup. So you need secure access to these Airflow UIs. And the solution we came up with is using Google App Engine behind identity-aware proxy. So to give you an example, let's say I'm hosting this app, trevorsworkflows.appspot.com. So what you would do is you'd have this Airflow web server as a service for App Engine, and you'd configure yourself as an IAP web user. So if I go to use this Airflow web server, I'll be able to get in just fine and use it. If my manager wants to see what I'm doing, I'd have to give him access. So that's nice in case maybe I'm just processing memes or something. I'm not sure. So as a bonus, you can access this from anywhere. As long as you're allowed to, you just go to that website and log in, assuming you have a Google supported login. And in the future, the caveat is there's all or none access. So in the future, we're looking to integrate with RBAC. Thanks for working on that, Joy. And here's an example of like just what the IAP interface looks like, and this is what it would look like if you get denied. So moving on to Airflow on GKE. So you need secure, scalable, configurable worker pools. So our solution was to run it on Google Kubernetes engine. So as a bonus, when you do this, you can build your containers like the Airflow worker, the Airflow web server, if you're running it that way, in Container Builder. And you can store it securely in Container Registry, those are both Google Cloud Platform products. Another bonus, you can keep your Airflow configs consistent. This is something you need to do if you're running with Celery. You can use config maps to do that. And just for future work for us again, this will make it easier to switch to the Kubernetes executor. Config map is a Kubernetes object type. I'm not sure if that's the proper term for it, but it's pretty much you store configurations as a Kubernetes object, and it's mounted for all of your pods. For example, your worker and your scheduler, they can mount it as a volume. So what we do is we mount these configs as volumes, and the workers and scheduler look at them. Every time you update it, the workers and schedulers restart. So one more look at this overall architecture. Just a little bit more detail about GKE. So we have one Airflow scheduler running. You're not really supposed to have more than one running, as far as I know. Yeah, so N Airflow workers, so you might start at one, but you could go pretty high if you want to. Redis once again, and SQL proxy. And the nice thing about Redis and SQL proxy is they're available as Docker images. I think we use like Redis Alpine, and then SQL proxy is something provided by Google Compute Engine. So DAG and data distribution, you need to be able to distribute and access your DAGs and plugins quickly. I think a lot of people are using like some kind of Git workflow for doing DAGs. We decided we'd go with Google Cloud Storage for ours. So you also might need to have a large amount of data. And keep in mind, we're running these things on Google Kubernetes engine, so these nodes have a limited amount of storage. So we have this hybrid solution right now where we periodically sync DAGs and plugins to the local disk, and we mount data to a volume using GCS views. So how that looks is you might have your Airflow scheduler or worker pod, and you have these two directories available on all workers, home Airflow DAGs, home Airflow data. And the DAGs and plugins, we have this sidecar container that syncs these every 5 seconds, whereas on the data, we mount a volume using GCS views. So a couple caveats with that. The GCS views solution is somewhat new, and for some people it can be somewhat slow. We're still kind of waiting for feedback on this, and part of the reason is that you're not really in general supposed to have a lot of data in an Airflow worker. They're usually supposed to be kind of lightweight. And in general, every file access from GCS views must fit on the persistent disk while it's open. So if you had like a 10 gigabyte persistent disk, you still can't work with like a 100 gigabyte file from GCS. All right, so let's talk about scaling. First, we'll talk about the web server. So since it's hosted on GAE Flex, that comes with CPU-based scaling. So you can set a target CPU utilization, and what it'll do is set the minimum or you can set the maximum and minimum number of instances, and it will automatically scale your web server up and down based on the current usage of your CPU. So you can set the minimum if maybe people like to use your web server in bursty loads, or you could keep it pretty low to cut costs. On the scheduler side, we kind of talked about this already, previously, but the scheduler job is a single process, and the DAG loader is multiple sub-processes. So you can't really scale the scheduler out horizontally, but that's okay. With GKE, it's pretty easy to scale things up. So the way we would do it is we have a dedicated node pool with the label Airflow Scheduler. And the deployment for the Airflow Scheduler itself has a node selector, which chooses which node for that scheduler pod to run on. So let's just say you start that with one vCPU, but you decide you're maybe at 99% CPU utilization, you need to scale that up. You can create another node pool, maybe with 4 vCPUs, also set that label to Airflow Scheduler, and all you need to do is delete the old node pool, and GKE takes care of the rest, albeit a little bit of scheduler downtime. So then on the Airflow worker side, that's the kind of thing you might want to scale out with Celery. So to give it a concrete example, let's just say you have one Airflow worker here, and it's doing its best, but it's at 99% CPU utilization, and you need more workers. So GKE can detect this, and what it'll do is make a request to have another Airflow worker. And this gray box here, that represents a GKE node, which is basically a vCPU, or yeah, vCPU running, or VM running GKE or Kubernetes. So the first request will go through, but let's just say these workers are still struggling. They're still at 99% CPU utilization. What GKE can do is it has something called node autoscaling. And node autoscaling will automatically detect that there's requests that are being made that aren't being satisfied. And based on that resource starvation, it'll realize it needs to make another node, and that request will get satisfied. So to review, you have this pod autoscaler. So that's minimum replicas, maximum replicas, and that'll determine how many Airflow workers there are. Then there's a node autoscaler. That's resource-based, so you can set a min size and max size. So caveat is one thing where we haven't completely solved yet is autoscaling Airflow configs. So if anyone has ideas for this, happy to talk about it after. So some of those are like parallelism, DAG concurrency, and max active runs per DAG. And you could just set those very high, although I'm not entirely sure if that will cause bad effects. I don't know if anyone else knows that. Again, got a shrug from Max. Max says it should be fine. Yeah, so it's probably not the biggest problem, but it's one thing we're considering. So let's move on to the last part, Stackdriver, logging, and monitoring. So on the Stackdriver logging side, running in GKE gives you Stackdriver logging capabilities right out of the box. So it's kind of hard to see, but here I'll show a bigger picture in a second. Here's like an example of what Stackdriver logging would look like, and this is just what you get automatically from running a container in GKE. Then there's Stackdriver monitoring. So Stackdriver lets you define user metrics, but it also exports system metrics. So you can use this for alerting, for creating dashboards, and this would work if you're running it on cloud or on-prem. So here we have, for example, a dashboard we made, pod CPU usage. So digging into Stackdriver logging a little bit, here's a bigger picture of what that might look like. So you can see we've like selected a GKE container and specifically the Airflow worker deployment. And we're running a tutorial DAG here. So this is a good backup to the gcs.task logger. We usually use that as the main one, but if anything goes wrong, we'll check here too to see if maybe it failed to dump to GCS from the task logger, but it still made it through from Stackdriver. Another nice thing about logging to Stackdriver is log-based metrics. So you can use this. This is like not a perfect example, but you can use this to alert based on DAG status. So let's just say you want a very like poor man or a straw man's approach to health monitoring. You can check. You can make a log-based metric looking for logs that look like marking run tutorial successful. And you can use this for liveness monitoring, and you can actually configure alerts. So here we have a user-defined metric where you can see every 5 minutes we have a single instance of this log being output. And here there's actually like a little issue with Airflow, but we won't worry about that right now. So then I talked about dashboards. So here's a few other kinds of dashboards you can make. And last, I'll just talk about alerting. So you can configure based on these user-defined metrics, alerts based on certain thresholds. So in this example, maybe you want to alert when your Airflow scheduler is almost at max CPU utilization, because that would tell you that it's probably time to scale up. All right, so that's the end of the presentation. Are there any questions? So that's not a question I can confirm or deny. So yeah, there's some things I'm not allowed to talk about, but I'll do my best. Yeah, so I'd say, oh yeah, I'll repeat this question. Also oh yeah, so with your question, the question was how much would this cost usually per month for a user? I believe it's in the ballpark of, like, if let's say you have 3 workers, Cloud SQL instance, GAE web app, scheduler, worker, or I already said worker, but I think that's about $100 a month, on the order of that. But you can check the cost yourself. We don't have anything publicly clonable right now. Yeah. The proxy in front of the scheduler, or so the question is, is there a proxy in front of the scheduler that handles like load balance? Or I can go back to that slide if it helps. Scheduler is running on only one instance, so I guess that's why I'm confused, because you can't really load balance a single instance. Okay, yeah, scheduler is only on one instance. Right. Yeah, and the comment was that you can use an init container to initialize the config map. Right. Yeah, I think that's actually something that we do as well. I'm not as familiar with that area. I think that's something we do. Thanks. Yeah. So yeah, we sync the DAG every 5 seconds. That's using rsync. I'm not too familiar with how that protocol works, but it translates to some, I think, like a class A or class B GCS operation. So that can be a little costly. So like you can control cost by making that less often, but then you'll have more latency. Yeah. So had, or every 5, did I say every 5 seconds, the rsync happens. So um, right. Yeah, actually, yeah, I think I know what you're talking about. I believe that's a configuration you can set, and I'm pretty sure we dialed that a lot further down to like maybe 30 seconds or less, to account for that. Oh yeah, and the comment was, or the question was, basically the comment was the scheduler pulls DAGs every 5 minutes maybe, but according to Max it's every 1 minute, so it wouldn't make sense right off the bat to sync every 5 seconds. Yeah, so Cloud SQL is everything from Airflow DB. I'm more on the infrastructure side, so I'm not entirely familiar with everything in there, but I think that's like DAGs, DAG, DAG. I forgot if that's a table, but anything that would be Airflow DB is Cloud SQL. Everything else is GCS, so that includes like DAGs, plugins, logs. That's the main ones. Yep, worker logs go to cloud storage, and there's a GCS task handler for that already. I think that might have been contributed by WePay. So you can do that like right off the bat, just by switching from like file.task to gcs.task. Which one? Oh yeah, the question is what's the SQL proxy for? I'm not too familiar with it, but I think the gist of it is that there was issues like connecting directly from GKE nodes to Cloud SQL. I forgot what they were, but the solution is to use something offered by Cloud SQL itself, a container called the SQL proxy, and it will expose a SQL service to all the other GKE containers within your cluster. Any other questions? Okay. Anything on the chat? Nope. All right. Thanks, everyone.